All right, here's a good solid video on the Chinese J20 and high alpha maneuverability. So as you know, China's got this new plane, this new fighter attack plane. We did some videos on that. See our YouTube channel, go back and find them. Now, what's the deal with high alpha? And that's when the plane is flying straight across the horizon, but its nose is way up in the air. It's basically like a motorcycle popping a wheelie. Why this is so important is the higher you can get a plane to do high alpha attack, high angles, and the more stable it is, that's a way of showing off how maneuverable that plane would be in a dogfight. That's why airplane designers are always testing high alpha. Now the challenges to high alpha testing have been when the plane does a pop a wheelie like that, the first thing you have is the wings stall out. So when you use your ailerons down, the angle of attack gets greater and the plane is going to stall on the wing and actually roll the opposite way. So if you can get past that, your next issue is you can't get your nose up high enough because you give it up elevator and that tail is only going to bring the nose up so much. And then the next issue you have is on the yaw is you get your nose even higher and now the bottom of the plane is blocking your vertical stabilizers. You lose yaw stability and the plane slides out, rolls over. So the way that they solve the roll is, and this works really good in RC, is spoilerons. You kick the ailerons both up so now they're more level with the horizon. For pitch, planes will use canards as well as thrust vectoring in the back. So the canards can kind of re-angle into the wind, and then the thrust vectoring, I mean, that's really good. That's like cheating. That's just using your jet exhaust to just force that tail down, which brings the nose up. That's why most modern fighters are going with thrust vectoring. It just gives you a big advantage. And so for yaw, what do you do with yaw? Now, one way is you can rely on the thrust vectoring, and that does help. But I'll tell you, when you have a plane that is relying solely on thrust vectoring for stability, you have to have the power way up and you have to have the speed way up because you're basically compensating for airspeed. So if you have control surfaces that are getting some airflow over them, even if the plane's only going 30 miles an hour, that is going to greatly help. It's going to reduce the workload on your thrust vectoring. So the best thing that you can do is have your vertical stabilizers drag behind the plane. Therefore, when it's in high alpha, they're getting fresh air. Look at that. Oh, that's why they have it like that. So what does this mean? This means any plane shaped generally like the J20, the Delta Canard V-tails in the back idea, is going to be the king of high alpha. So let me know what you think in the comments as far as high alpha planes. What planes have you flown that are really stable in high alpha? What kind of fighter planes do you see out there that you think that could beat the J20? If you're getting into RC planes, we have the ultimate course. It's everything you need to know to get into RC planes. Several hours of audio, pictures, diagrams, videos. These are the planes you want to get. Here's how you set them up. Here's what you need to buy. Here's what you need to invest. Everything you need to know. It's the fastest, most efficient way to get into RC planes. That's at our website, rcpowers.com. Next Monday, we'll have part 2 of this video talking more about our high alpha design projects and experiments.